Here we are at segment 3 of unit 3, right triangle trigonometry. We have managed to get through quite a bit of this agenda here. Let's check it off. This one, of course, we've done all of this, and then in segment 2 we worked on solving right triangles. You worked at home and then in the classroom on solving. The next two sections, this one and the following one, are multi-step problems. Persevere, a very important word here. A trig student is good at perseverance. If there is no other reason for you to study trig, it would be to learn to persevere in problem solving. So we're actually working through multi-step problems. I think all of these, let me check it out, I think all of these are in your workbook. So with your calculator handy, we'll get started with this. We have alpha, which is known. Okay, that one is known. It's 25 degrees. And beta, which is also known at 40 degrees. And this length, BC. Wow. All right. And we want to find the length of AB. So the length we're interested in learning is right here. Now, we're very good at solving right triangles. So we've got two right triangles to solve here. Which one should we go for first? Well, the one we need to go for first is the one where we have two measures, which would be DBC. Okay, so we're going to start with DBC. I've got, no, that's not the one I want. This one is the one. I'm sorry, I'm gibbering to myself. Okay, so the triangle we're going to use is this one here, and the reason we're using that one is because that's the one that has the measurements that we need. Okay, so we've got 20. No, this one is 12. This is equal to 40 degrees, and of course 90. So we really need to figure out what this is, don't we? What is this length? That's what we really need to figure out. So let me just draw that triangle all by itself. Okay, we've got 12 here, 40 degrees here. So we know what this one is, right? This has got to be 50 degrees. Maybe we don't even have to use that. And what we want to do is figure out what this length is. So if we have x, I'm going to call this x, equals, oh, I'm having some problems, aren't I? What a mess. Okay, try it again. X equals 12. Y is unknown, and my angle theta equals 40 degrees. So what ratio can I use that uses just x and y. That's right, tangent. We know that tangent of 40 degrees is going to equal y, which I don't know, and that of course is DC, and x, which I do know, that's BC, it's 12. So I could re-express this as y equals 12 times whatever the tangent of 40 degrees is. Let's pull over the calculator. It's going to be so useful to have a calculator handy. Okay, now usually when I start up, my mode is radians, and yes, indeed it is. So we're going to change that over to degree. And now I'm going to say tangent of 40, which is equal to negative. I must have done something wrong. Let's look at the mode. Oh, yeah, because I know 40 is in the first. Somehow I didn't get that to stick. All right, there we go. Try it again. Tangent, whoops, clear. Tangent of 40 degrees. It gave me tangent of 40 radians. Whew. Good thing I know that it should be positive. All right, that makes more sense. And we're going to say times 12, right? So 10.07, I'm going to call it. So right here I've got 10.07. I'm actually going to erase my work because I don't have enough room to do the rest of it. You, of course, can use an extra piece of paper, the back side of the previous sheet. You shouldn't erase your work. All right. So 10.07 is this distance right here. Now I can look at ADC. Remember, what I actually want to find out is what this length is. But with ADC, here's C, D, and A, I know that this is 10.07. I don't know what this is. I don't know what this is. I do know a portion of it, but that's not going to help me. I know that alpha is 25 degrees. And I want to find out what this is. Yeah. So I don't need to know the hypotenuse, but I need to know this. So which ratio should I use now? That's right, we'll use tangent again. Tangent of 25 degrees. We know what the ratio is here. It's y over x, so it'll be 10.07 over x, and x, of course, is this whole length, AC. So, let's see, I'll multiply this. Okay, so x equals 10.07 divided by whatever is the tangent of 25 degrees. Let's get our calculator over here and figure that out. Turn it on. Tangent of 25 Okay, it's 0.4663. Pull that out of the way for a moment. 0.4663. So I want to divide that into 10.07. So I'm going to convert this into a division by taking the reciprocal, which looks like that, times 10 point, and I've got it all up here, so why don't I use that? 0.6919557. We don't need to be that precise. I'm just obsessive compulsive. Okay, so my x is 21.59. X equals 21.59. So this whole length is 21.59. Well, if the whole length is 21.59 and I want to know what this is, what do I do to find out what AB is? The length AB is equal to 21.59 less 12, right? So if I subtract 12 from this, should be an easy enough thing to do by hand, but let's just do it here. Negative 12, 9.59, 9.59. So this was a great example of being given some information and having to solve first the smaller triangle so we could get this length, and then the larger triangle so we could get this leg, and then we had to subtract 12 from it. Okay. Example 15. I'm going to use the same picture and the same angles, but what we're going to change is now we know what side AB is. I'm going to get my eraser out and erase all of this. Okay. Ooh, that was a big eraser. Not used to using one quite that big. Well. Okay, for this we have the same picture, and we know this angle and this angle. The side that we know now is this one here. And the side that we would like to know is this one. What is this length? How could we go about doing that? Well, let's see. What are some things I can say about this? By the way, even though I'm going to work up here, I'm not working on this problem. I'll cross it out. I'm just going to take advantage of so much space up here. Some things I know I could say are tangent of 25 degrees equals CD over 12 plus BC and tangent of 40 degrees equals CD over BC. So I've got actually two unknowns here, but I have two. Let me mark them. This is an unknown, this is an unknown, this is an unknown, this is an unknown, but I have two equations. So if I have two equations with two unknowns, I should be able to figure it out, right? Let's solve for CD. I can say that in this one, CD equals, what's a tangent of 25 degrees? I should know what, that's why you're in better shape than I am, because I turned my calculator off. Okay, I erased my work. 25 degrees. Tangent of 25 degrees is 0.4663. Okay, so that's going to be 0.4663 times 12 plus BC. And on this equation, I've got CD equals, now I've got to do tangent of 40 degrees. Tangent of 40 0.8391, I should say. 0.8391. 0.8. Oh. 0.8391 times BC. So I could solve for BC. I don't know if I'm doing this in the most direct way. I could say, well, two things that are both equal to CD must, of course, be equal to one another. So that would be .8391 BC equals, I want to say 0.4663 times 12, 0.46630765, yeah, you can tell I'm obsessive compulsive, right? Times 12. Okay, so that'll be 5.5957, we'll say. 5.5957. What did I do? I just distributed that. I did the multiplication. Plus 0.4663 BC. Now remember, I'm solving for BC here. Let me just mark it. Solving for BC. We said CD and CD equal to the same thing, so I made an equation. What did I really do? I'm substituting, right? So let's subtract 0.4663 BC from both sides. And then our equation will look like what? Okay, let's do the subtraction right here. We have 0.8391. We want to subtract 0.4663. That'll give us 0.3728. So we get 0.3728 BC equals 5.5957. Now, I want BC all by itself. It's currently being multiplied by this number, so I'm going to do the opposite, which will be divide by that number. And I do that to both sides. And then I will have BC equal to, let's pull it over. I want to divide this number by 0.3728, so I'm going to take the multiplicative inverse, the reciprocal, times 5.5957. Gives me 15. Equals 15. 15, well, I could say 0.01, I suppose. So if BC is 15.01 and this is 12, then I know that AC is 27.01, right? And of course, what I want to find is that length there. And I know this one, right? I know alpha. That's 25 degrees. So in order to find this, let's call it a y. What am I going to do? What? Yeah, we're using the tangent ratio a lot here. Tangent of 25 degrees equals our unknown, which is CD, right? CD, and this is A over here, over my y, which is 27.01. So my CD equals the tangent of 25 degrees, which I have kept up here, 0.4663 times 27.01. Let's do that, and we will have that length, won't we? Turn this on. And we'll do tangent of 25 degrees times 27.01 equals 12.59. Okay, same picture, but we're going to change the values. Now A is going to be have an alpha of angle measure of 35 degrees, and beta will be 68 degrees. Hmm. 68 degrees. And what else do we know? AB. This distance here, A to B, which is 76.5. Those are our givens, and we want to know what the length of this is. How would we figure that out? Gee, I mean, it doesn't sound that different, does it, from what we did over here? We've got this given. We're looking for this one. We've got these two angles. So it's the same. Whoops. It's the same problem again, just with... Okay, here's a little challenge for you. Can you spot the goof? It's coming up. Different numbers, isn't it? So what can I say about CD? I can look at, let's call, okay, this distance here is BC, and this distance here we're going to call CD. So when I talk about the tangent of alpha, 35 degrees, I can say that is equal to the vertical, CD, over the horizontal, which is 75.5 plus BC. So I have two variables here. This is a number I can find. And then I'm going to do beta. The tangent of beta is 68 degrees, is equal to CD over BC. So I have the same two variables I had previously. This is good news. I can write these equations as CD. I'm going for the first one here. CD is equal to, let's find out, what is the tangent of 35 degrees on? Tangent of 35 degrees is 0.7002. 0.7002 times 75.5 plus BC. And then this one looks like this. CD equals, see, what's the tangent of 68 degrees? All right, tangent 68 degrees, 2.4751. Okay. 2.4751. BC, right? So I just multiplied both sides of the equation by BC. In this one, I multiplied both sides of the equation by 75.5 plus BC. Ended up with this. So we'll keep going. Let me just mark our variables here. So I've got CD and I've got BC. This whole expression equals CD, and so does this. So I can make them equal to each other. I can say, let's do my multiplication as I go here. 0.7002 times 75.5 is 52.8651. So I can say 52.8651, that's this distribution, plus this, plus 0.7002 BC is equal to 2.4751 BC. All right, so I did substitution there. Since they're both equal to CD, I said they are equal to one another. Now I just have one variable to solve for, which is good news, isn't it? You bet. So I'm going to subtract 0.7002 BC from both sides. Let's do that. So 2.4751, we're going to subtract 0.7002, and we will have 1.7749 BCs. 1.7749 BC is equal to this, right? This zeroed out. 52.8651. So, of course, since I want to get BC all by itself, I'm going to divide both sides by this number. Let's do that with our calculator. Remember to divide, I can take the reciprocal, multiply by the reciprocal, which I'm going to do, times 52.8651. 29.78. So BC equals 29.78. I could take one more. Okay. So there's the variable I was looking for, BC. Now, why was I looking for that? I wanted actually to find out what this is. So I can use just this triangle here this time. Okay, last time we added these two segments together and we used the outside triangle. This time we'll use the inside one here. So we're just going to focus in on this one. Oh, I'm having fun drawing colors on here. Too bad, I'm making you wait. Sorry about that. All right, so what are we going to do? We're going to do the tangent of 68 degrees equals CD, which is what we were after all along, over BC, and we have a value for that now, 29.785. Or we could write it this way, CD, that length is equal to the tangent of 68 degrees times this shouldn't take us too long to get now, huh? We're almost there. So I'll push it up a little more so it's not so in the way. Tangent of 68 degrees. So 2.45475. 2.4751. I didn't have to do that. Look, it was right there all along. Oh, yeah. Times 29.785. So CD is 73.72. Does that make sense? 73.72. We don't have a unit of measure, so that is going to have to do. Let's see, does that make sense? Line segment CD. Okay, I think that's enough for today. We have a lot of word problems yet to do, and I haven't even gone over the guidelines. Read those in class, and then we'll do some of these in class. Real life applications, surveying problems. Ooh, we're getting into the real world. All right, so we've got some problems for you to do either at home or back in class. It's fine with me if you wait and do them in class. 17, 18 in your notebook. Angles of elevation and depression, 19 and 20, 21 and 22, and then we've got lots more. So you're going to have quite a bit of work to do here. But we love it, don't we? Oh, I nearly forgot. Did you catch the goof? Did you catch that? I copied a value, a length of 76.5. That was the given, right? That was the given for the length AB, right? AB. The length of AB was equal to that. Okay, and what did I use in my calculations? In my calculations, I used 75.5. Oops. 75.5. Oh dear. So you probably did it correctly, right? If you use this, you get the answer for the length CD. You get an answer of 74.70 when you round it. So that's what you get if you don't make my mistake.